you have to do it.
Okay? So, here we go, everybody.
And this is what the quiz is going to look like?
We're paying attention.
Okay, cool.
We are looking at section 3.5, problem number 9, which said, it's a logarithmic equation. We solved some of these yesterday. How do we solve this? What do we have to do first?
Add the 5. Just kidding. Oh, you do 4 to the negative 1.
That's what we do. We do 4 to the negative first equals x minus 5. 4 to the negative first equals x minus 5.
And then
Katie Roth, you're making me nervous. What's 4 to the negative first mean? 1/4. Remember, negative exponents mean 1 over. So 1/4 equals x minus 5. So now what do I do to solve that? Add 5. So x equals 5 1/4. 5 plus 1/4. 5 1/4. That wasn't too bad. Remember always, 4 to the negative first equals x minus 5. That's the key. Okay, anybody else find one? Number 5 is an exponential. We did some of these yesterday too. What's the first step to solving this? Dividing by 2. So 10 to the negative x over 3 equals 10. Whoa. The key to doing these problems is making these numbers match. They match. That exponent is a 1 there. 10 is 10 to the first. Since these two numbers match, then this has to equal this, doesn't it? So negative x over 3 equals 1. Thank you. Negative x equals 3 and x equals negative 3. Very good. Bryce? Which one? 6. Okay, this last one, pay attention. Step 1. Divide by 3, so we have 5 to the negative x over 4 equal to 5. Bryce, it's exactly the same as this one, because now we have our bases matching. Exponent here is 1, so negative x over 4 equals 1, negative x equals 4, and x equals negative 4. All right, let's get our note sheets out. We are now on the back side of page 28. And we're in section 3. We need a calculator. Why do we need a calculator? Can anybody tell me why you think we need a calculator, maybe for problem 3A?
Because 3 can't change it.
Say that louder.
If 3 can't change it.
Exactly. This problem, we had 5s and 5s on both sides. Here we have a 3 and a 7. In order to do that, those numbers have to match. Can you make a 3 and a 7 match? No. A 3 and a 9 we could do, but not a 3 and a 7. So that's how we know we're going to need a calculator to do this. Okay? This will be on the calculator part of your test. Problems like this will be on the no calculator part of your test. how do I solve this? Well, the whole problem is that that variable is an exponent. That's the problem. So I'm going to take the logarithm of both sides of the equation. Now, before you think to yourself, why would you do that? Stop and think about it for a minute. What happens to this exponent when there's a logarithm now in the problem? What can I do with that exponent? Move it. Now it can come out in front. Remember, in logarithm land, exponents are coefficients and vice versa. So I have an exponent, I'm going to turn it into a coefficient. So I have x log 3 equal to log 7. So x equals the log of 7 divided by the log of 3. I'm just going to type that in on my calculator now. Being really careful when I type in log 7, it's going to put a parentheses here. Make sure you close that parentheses before you hit divided by. So log 7 divided by log 3. I got 1.7712. What about you?
Yep.
Make sure you're closing this parentheses. That's where the big issue comes. Alrighty. How am I going to solve this? I take the log of both sides. And why do I need to do that again? Why do I mess around taking the logarithm of both sides? What does that now allow me to do? Makes the x come out in front. And then Abby Brady, how do I solve for x? I want to know what x equals. What will I have?
X equals log 4 over log 10.
Oh, whoa, 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 whoa. Be careful. Abby, write it down. You need to get rid of this. So you have plain x over here, so you're going to divide by the log of 4. So it's going to be the log of 10 divided by the log of 4. It's like a regular equation. You're solving for x. So let's make sure we can all type that in on our calculators. This time I got 1.6610, I guess, if I round it. Jabron, you keeping up here? You sure? Okay, Baumgartner, you still with me?
I'm already done.
You're already good. You done the next one too?
Oh, no, I just
Okay.
did that one.
Okay, let's look at this one. Now, there's ugly decimals, but does that really matter? No. We're gonna use our calculator, so it doesn't matter. What's step 1?
Log.
We're gonna take the logarithm of both sides. And I'm doing that, Veronica Stemke, so what happens? What can I do now that I took the logarithm of both sides? So x is going to come out in front. And Jordan Bruns, what will I end up typing into my calculator? You are exactly right. Good job. So let's type that in. I got 4.1491. I am just round, there's no directions here, so I'm just rounding. We'll round it however the directions tell us to, like if it's a test or something. Everybody good? That's pretty easy, wouldn't you agree? But let's look at the next one because there's a little bit of a complication in it, but I think you know how to handle it. Because we kind of ran into this complication yesterday. I think you know how to handle this. Divide by 6, very, very good. You gotta get rid of this extra number. Whether you're doing it like we did yesterday without a calculator, or whether you're doing it today with a calculator, doesn't matter. That's gotta go. So we'll have 2 to the x plus 1 equal to 3. Now don't let that exponent scare you. We handle it just like a plain x. So what's gonna be our next step? We're gonna take the logarithm of both sides. Now, what happens now? This guy is going to come out in front. So we're going to have x plus 1 log 2 equal log 3. Now, can I still divide by log 2? Mm-hmm. But it won't be x equals that. It will be x plus 1 equals that. So x plus 1 equals log 3 over log 2. But remember, you're solving for x. So you're going to have one extra step. What are we going to have to do? Subtract the 1. So we're going to take whatever log 3 divided by log 2 is. That'll be some number our calculator will tell us. And then we'll have to subtract 1. And this time I got 0.5850. Did I do that right? Okay, now I'm going to do one more with you because it's a little bit different. Do you notice the problem E? We're ready for problem E now. It has an E in it. Any idea how that might change things?
What is E equal?
E is Euler's constant, we talked about, it's the base of the natural logarithms, and it's a number just like pi. It's just a symbol for an irrational number, and it's 2.718. Like pi is 3.14159, E is 2.718. Well, let's get it started and see if you can figure out maybe what the special little trick here is going to be. So let's look at the problem. What do you think will be the first step? Divide by 81. Kids, I just said, I'm going to say it again. We're all kind of drowsy today. We're in slow motion. We've really got to get this. You can't do the problem when there's this extra number out here in front. He's got to go. Whether we're doing it by hand or doing it on our calculator, that can't be there. So we're going to divide that out first. So I'm going to divide by 81. So e to the x equals 200 over 81. I'm not making that a decimal. It's a fraction. It's 200 over 81. That'll be fine. I can type that in on my calculator. Now, what's the next step supposed to be? I can't pull the x off yet. I got to take the logarithm of both sides. But since this problem has an e in it, I'm going to ln both sides. Now that's perfectly legit, people. Remember, I don't do illegal things. It's perfectly okay. We're going to take the natural logarithm of both sides. And the reason that we do that is because this just equals x. These cancel each other. Because ln is log base e. So if I take log base e of e to the x, I just get x. That's one of my properties. So x equals ln 200 over 81.
Put a decimal.
What?
The decimal answer, whatever.
I'm going to get the decimal answer. Yeah, now on my calculator I am. So I'm just going to say ln 200 divided by 81. And the answer is 0.9039. Now, why did I use ln in that problem and I hadn't used ln at all up till then? What did this problem have in it? An e. So when I look at the next one, it has an e in it. This is F, problem F. There's an e in it. So when I'm ready to take the logarithm, I'm going to use ln instead of log. But I'm not ready to do the logarithm yet. What has to happen first?
Divide 17.
Divide 17. So e to the x equals 93/17. Now at this point you have a choice. You can log both sides, you can ln both sides. ln is so much easier because there's an e. So I'm going to ln both sides. What is ln e to the x? Just x. Because this means log base e of e to the x. The answer is 1.6994. Did you match that? Everybody match it? Okay, at your tables, I want you to do G and H for me.